In the last video, we computed the slope of a curve at a particular point. And here we have the formal definition of what we mean by slope for any function. So given any function f, and we're going to look at the point A, then the slope of that function is the standard part of f of a plus delta x minus f of x divided by delta x for every non-zero infinitesimal delta x. So we'll talk a little bit about that issue in a minute, the fact that it has to be for every. How do you go about checking every? That will be a challenge for some functions. But right now, hopefully the last example in the video, you have an intuition of what we mean here. We're looking at the change in y over the change in x for an infinitesimally non-zero value delta x. And we can extend this idea, instead of having to do it for every point, like we did in the last example, we can extend this idea and create a new function that returns the slope of the function at any given point. So f prime is, or the derivative of f, which we note with f prime, returns the slope of f at the given point x. So in symbols, we have f prime of x is the standard part of f of a plus delta x minus f of x divided by delta x, which we can simply think of as the standard part of the change in y of change in x, again, assuming that that slope exists. So let's run an example here. Let's take the function, say, f of u is equal to, let's say, just the square root of u plus 2. Then f prime of u is the standard part of the change in y over change in x, which is simply the standard part of the square root of u plus delta x plus 2 minus f of u plus 2, all divided by delta x. Now note that we can't go straight through and compute the standard part. We can't use the division rule because the denominator would be 0. The standard part of delta x is 0. And so we've got the difference of radicals, and we've seen this before in computing standard points or standard parts. To do this, we multiply by the conjugate. So this is equal to the standard part of square root u plus delta x plus 2 minus square root of u plus 2, and still all over delta x, but now we'll multiply by the conjugate. So square root of u plus delta x plus 2 plus the square root of u plus 2, and we'll write this again, so we're actually multiplying by 1, so this is u plus delta x plus 2 plus square root of u plus 2. So multiplying this out, we get that this is equal to the standard part. So a nice thing about conjugates is this is difference of squares, so the radicals go away. So this is just u plus delta x plus 2 minus u plus 2, all divided by delta x times square root of u plus delta x plus 2 plus square root of u plus delta x. And now when we do the subtraction, this u and this u will cancel, this 2 and this 2 will cancel. So what gets left behind in the numerator is just delta x. And in the denominator, we still have delta x times square root of u plus delta x plus 2 plus square root of u plus delta x. And the delta x cancels, so we get this delta x canceling with that. And so we're looking at the, whoops, sorry about that. We're looking at the standard part of 1 divided by square root u plus delta x plus 2 plus square root of u plus 2. And now we can apply the standard part. The standard part of the numerator is 1. And as a standard part, remember, it'll move through the radical, move across addition, and u is a real number. Delta x is an infinitesimal, so it'll go to 0. 2 is a real number, u is a real number, 2 is a real number. So this really, when you let the standard part run its course, will be 1 over square root of u plus 2, because that delta x is 0, plus square root of u plus 2, or more naturally, 1 over the square 2 times the square root of u plus 2. And so this is our derivative of f prime. That's f prime of u, the derivative of f. And so now we can tell ourselves, we can figure out at any point what is the slope, any point where it's defined. So we could say, well, so remember our original function is f of u is equal to square root of u plus 2. So we take anything in our domain here. So I don't know. So at the point maybe 2, 2, the slope is given by f prime of 2, which is 1 over 2 square root of 2 plus 2, which would be 1/4. So we didn't have to, so at this particular point, we didn't have to go through all the work again because we did it abstractly. And so now we can figure out the slope at any point. There is one place to note that at -2, we have no slope. Because if we put it in, f prime of -2, by definition, would be 1 over 2 square root of -2 plus 2, which is 1 over 2 times 0, which is undefined. Or really, this thing is going, if we looked at standard parts, this thing would be going to infinity there. And so it fails to exist. So we could say that the domain of our derivative, so the domain of f prime of 0 is simply the interval. Well, we know that we need the inside to be positive, and we can't be at -2 because that makes it 0. So it's going to be anything bigger than -2. So it'll be -2 to infinity.